Today, our team will be presenting our research report on the impact of COVID-19 on Malaysia's unemployment rate. Next slide. Our complete presentation consists of 6 parts. Today, I'll be focusing on the first 2 sections. Next slide. In part 1, I'll provide background information on how the COVID-19 pandemic triggered global economic shocks and specifically affect Malaysia's regional economies to varying degrees due to different industrial structure. Our research has 3 main objectives. First, to analyze the pandemic's impact on Malaysian unemployment using state-level panel data from 2050 to 2023 through advanced econometric methods. Second, to identify and evaluate the key mechanisms driving these effects. And third, to develop evidence-based policy recommendations to address unemployment challenges and support economic recovery. In part 2, I'll show our theoretical framework, which draws our 4 key economic theories. Each theory provides a distinct mechanism through which the pandemic affect labor market across different regions. For the first theory, Kasnitz shows sectors have varying employment capacities. Malaysia's growing service sector proved especially vulnerable during lockdowns, with tourist destinations suffering most. Our service variable tests if service-dependent regions experience high unemployment. The second theory in Blanchard's ADAS model, COVID-19 represents an external shock. Movement control orders reduce both demand and supply. Low-in-case variable measures shock intensity and is expected to correlate positively with unemployment rates. A third theory, Oken's law, established a negative correlation between GDP growth and unemployment. Supply chain disruptions particularly affect Malaysia's manufacturing sector. GDP growth and IPI variables test if this relationship held during the pandemic. The last theory, Pigu's labor market models suggest vaccination affect both supply and demand side. High vaccination rates reduce health risks and boost confidence, allowing industry reopening and employment recovery. Next up is my team member part 3.
The third part is data source and sample period. We collected data from 13 states in Malaysia covering from year 2015 to 2023. This allows us to capture what happened before, during, and after pandemic. Our main focus is unemployment. The unemployment data comes from the Department of Statistics Malaysia. We also include several important factors that may affect unemployment. First, we added GDP growth rate to capture the overall economic performance, and we used the total number of confirmed COVID-19 cases from each state to reflect how serious the pandemic was. Because the case numbers were very different across states, we used the log of this number to make them more stable. The third one, we added vaccination rate from the Ministry of Health, which tell us how much protection each state had against the virus. Next, we include the share of service in each state's economy. This helps us see whether states that rely more on service experience the higher unemployment. Since the service sector were heavily affected by the lockdown. And finally, we use the share of manufacturing in GDP to reflect the industry strengths of each state. Next slide, please. And we build a panel data model where the unemployment rate is the dependent variable. The model includes these five factors we just discussed. The first one is share of service sector, log of confirmed COVID-19 case, and share of manufacturing sector, GDP growth rate, and last the vaccination rate. So in simple terms, the model help us study how the pandemic vaccination, economic structure, and the GDP growth affected the unemployment across state and over time. We can use the panel data method so we can compare the state with each other and also see how things change over time. That's all from my part. I will pass to you next presenter.
Okay, so the part five, I will cover the results and the discussion of our study. And first, let's begin with the descriptive statistics from 2015 to 2023. The unemployment rate in Malaysia fluctuated considerably across days, and the average unit unemployment rate was about 3.5%, with some states reaching up to 8.9%. For long case, the logged number of confirmed COVID-19 cases show substantial dispersion due to its concentration during the crisis period. Vaccination rate also display high variability as mass vaccination was only implemented from 2021. In contrast, the variables like GDP growth rate and the share of the service sector remained relatively stable, and these patterns reflect the regional difference in economics, resilience, and pandemic exposure. So the next, we apply several unit root tests to examine the stationary of our variables. According to the Levin-Dinh test, UR long case API and stationary, but SERV and VSR were not stationary across all methods. But this outcome is not surprising because for SERV, the survey sector grew steadily until 2019, but COVID-19 caused an abrupt disruption in 2020 to 2021, making the time series not stationary. And for VACR, it had no value before 2020 since vaccination campaigns only began in 2021. So this structural breaks explains its not stationary behavior. Based on these findings, we conducted a pinal co-integration test, and the Padroni test results showed that 5 out of 11 statistics rejected the new hypothesis of no co-integration at the 5% significant level. So this indicates that despite the short-term fluctuation, but the variables exhibit a strong long-run relationship, so justifying the use of long-run panel regression. Okay, so the next is the model selection. And to select the most suitable model, we conducted three tests. The first is the BPLMS test. It shows significance, indicating the presence of random effects. Thus, the POLS model is rejected. So the next, we test the fixed effect model or random effect model. The second, we use the redundant test. And the p-value is also significant, so indicating the fixed effect model are present. So both FEM or REM remain possible candidate for our model selection. And the third is the Hussman test. And for the Hussman test, the p-value is the 0.33, suggesting the null hypothesis cannot be rejected. So both FEM and REM are consistent, but REM is more efficient. And next is our final model. The random effect model shows that long case had a significant positive effect on and employment, and highlighting the negative impact on the pandemic on labor markets. And IPI had a significant negative effect, demonstrating the role of industrial output in mitigating unemployment. And other variables like SERV, GDPG, and VACR had coefficient in the expected direction but were not significant. It may be due to the short observation period for pandemic-related policies. And the next, see we could see the random effect model. The R square is about 0.373, and the overall model was significant, but the R square is relatively low. So next, we need to further validate our model by comparing RAM with FEM. We could see this is FEM output. The FEM achieved a much higher R square of 0.85, indicating more stronger explanatory power. However, the significance and the size of some variables like IPI and SERV differed across models, indicating sensitivity to model choice. So, despite Husman test supporting REM, but FEM aligned better with economics theory and controlled for an observed heterogeneity. Hence, we select FEM as our final model. So the next is diagnostic test. The cross-sectional area test for heteroscedasticity showed significant variation in residue across days, and the p-value is equal to 0, is significant. But for the period LR test was not significant, so it's suggesting stability over time. And then next is residual. We could see it shows no severe shift. It may be supporting the assumption of no serial hydrosidicity across time period. Okay, so the last is our conclusion. For the findings, our study found that COVID-19 significantly increased employment in Malaysia, while industry production reduced it. But although variables like SERV, GDPG, and VACR followed expected signs, they also lack statistical significance. And for methodological insight, our Pinot configuration confirm a long-term relationship among variables. But FEM was chosen as the final model because for its robustness and theoretical consistency. And for policy, our results emphasize the importance of pandemic containment and industrial resilience in labor market stabilization. Okay, that's all of our presentation. Thank you.